All right, guys, so in this lesson, we're going to take a look at configuring another service set. And in this time, we're going to configure it for the service set that you would typically have your guest users on. So, but we're going to be using the WPA3 standards because we have to, because we're also going to configure it on the 6 gigahertz spectrum. And just to make a service available on the 6 gigahertz spectrum means we have to support WPA3. So, the easiest method to support WPA3 is configure an open SSID with no supplicants to really worry about, but let the device do a handshake whenever it associates to generate encryption keys between the user and the access point. Again, it requires no supplicant configuration just for the device to support opportunistic wireless encryption. So let's take a look at our topology real quick. And I've got this Pod 1 controller here that's a 9800L that we're going to be using. And we've got two APs. One of them is our 9136 6 gigahertz access point. So let's jump over to the controller. And what we're going to do is we just deployed a different policy profile and a different policy or WLAN profile, and we use the default policy tag, and we're going to keep doing that right now because we're kind of in a testing mode, right, building out some of these new services. But here's the thing, our policy profile, remember, each of these profiles are designed to be reusable elements. To make it easy sometimes, especially for newer installs, which is most of them, we will do one-to-one policy profile and WLAN profile, but it doesn't have to be that way. You can have a WLAN profile a policy profile. If you look at what's really in this, right, it's what happens on the wire. That's the way I want you to think of these policy profiles, is what happens to my session and what happens once it gets to the wire. So how am I switching the traffic, right? Central authentication, central DHP, and then we're tracking IP to MAC binding. That's fine. But over here in advanced, what happens to the session, right? So this is really the only thing that applies as far as the WLAN, but it's really about the client session once it's in the device, right? Once it's in the table, the client table, okay? So, and if these settings are gonna match, right? And as I grow and I start doing AAA backed, radius and all that kind of stuff, we may have ICE that's overriding our parameters, like VLAN I'm gonna have it assigned to, or different session parameters. In this case right now, if you look, I've got this mapped to the internet interface, and this is just for testing. So I can fully reuse this policy profile. I can use it twice, right? So what we're going to do is reuse that policy profile. And you look at it as a reusable element. Now, some deployments I've done, we basically will configure like a Wi-Fi training, ICE profile, policy profile, right? And then anytime I use ICE, for AAA, I basically just use that same reusable element over and over and over, right? So again, you don't have to create unique profiles every time, but some people do it just for simplification. I know if I've got a WLAN profile and a policy profile that are named similar, that are going to be designed, they're going to be used for each other kind of thing. So in some regards, it makes it easier, but in others, maybe I want it to be simpler as far as the architecture and know that, hey, if I'm doing central authentications, I use this one policy profile with these one session timers, and that's basically what we're doing, right? And it's going to map to a default VLAN or to a dead VLAN. Then we're going to allow ICE to override all of the parameters that we need to override, and that way ICE is really centralized at controlling everything, right? So you got some options, but let's go ahead and create our WLAN profile. That's really what this video is about, is that WPA3 and OWE. So we're going to add another one here, and in this one we're going to do WT. And what use case would I typically use this for? I didn't really specify which SSID we're going to use, but if we look in our design here, I've got some typically our strategy, our 4 SSID design. Now we're not really building these yet exactly like this. That's why I haven't been showing it. But this is kind of the 4 SSIDs that I tell people, hey, you get to start with these and then sell me on a reason why you need more, right? But where would I typically have an open type SSID? Well, it's typically going to be guest, right? So maybe what we do now is just build a WT guest. Again, I don't have to configure a supplicant. I do not need certificates to get this done. I just need a device that supports WPA3. So let's go back to our controller. And what we'll do is go ahead and drop 2.4. We want all of our networks to be 5 gig and or 5.6 gig networks. So we're going to do the WT guest, actually. And this is a way, there's a lot of security risk in legacy guest security, right? Because it's open. Typically uses a MAC address, and it's very easy to spoof MAC addresses and get guest access. But a lot of deployments, we have guests tunneled out to a DMZ, so they never get a chance to see the inside network, so to speak. However, there's still no encryption between them and the AP, and if somebody goes out to a coffee shop or a hotel, and there's a malicious actor that knows the skills that you can find in our wireless training videos at Wi-Fi Training, because we teach the ethical hacking side too, then we can take advantage of those users because they are basically very trusting of that service set because it's open. All I got to do is pretend to be that service set. You join to me, and once I'm in control of the network, I'm in control, right? You joined FirstNet at that point. So this would at least allow you to set up encryption between you and the access point. So it doesn't validate the server, it doesn't validate the client, but what it does at least do is make sure that sending data over the air doesn't get sniffed and, doesn't get sniffed and recorded, right? And people can't listen to what you're typing. Because anytime I'm doing insecure websites, and even in 2023, October, about to be 2024, there's still a ton of websites out there still using HTTP. Maybe not for the main page, but there's still a lot of services. And if they don't have their links right, then basically, or their server configured right, there may be a lot of HTTP sessions you're doing and web forms you're filling out, not even realizing that all that information is sent over clear text, right? So if somebody just listens, then they can de-encapsulate all that. But again, OWE, that's why it's so good to get people on WPA3, because even doing open networks, we're able to encrypt the session between the client and the access point without configuring any security on the client side. It's seamless. And I'm going to show you that. So we're going to leave 5 and 6 gigahertz, and you see there's requirements that have to be made for the 6 gigahertz to be active. So we're going to go up here and just start off by clicking WPA3, because that is a requirement to use that 6 gigahertz network, which is what we're going to do. And what we're going to do is come down here and do OWE. So if you notice, that disabled fast transition for me. It did enable protected management frames because that's another prerequisite of the protocol, right? So let's go ahead and click apply. And if I wanted to do web redirection with this, I definitely could, just like I did before, right? So we could do security and we could do MAC filtering, okay? And authenticate with a Radius server and do web redirection if we wanted to. It's all up to you and what you're trying to do. Now, another interesting thing I do want to point out here is, let's say you've got a guest network and we don't know that all of our devices support WPA3 yet, right? So it's great to just say, hey, turn this stuff on. But if my users can't connect to WT guest, that's going to be a problem, right? So what some people are doing is they're creating an extra service set, an extra guest service set. And they'll create it like WT guest underscore SAE, right? Or underscore OWE, or just WT guest secured. And then they'll hide the SSID. And I'm not a big fan of hiding the SSID, by the way, but I would rather have it open and just WT guest secured, or secure guest, or whatever you want to call it. But the point is there's a whole thing with hiding SSIDs. Clients don't work as well. Some of the newer clients should work very well because they're new and they should know about those things, but older clients wouldn't associate. But bottom line is, what we could do is we could say my WT guest is going to stay like it is today. We're not going to touch it. But for the clients that support this technology, we want to advertise that this service is available. So if they did connect to my WT guest, and let's say we weren't using WPA3, we could advertise that we were transitioning to OWE. And so what you can do is you can call out and say, I am transitioning to an OWE WLAN, and here's the WLAN ID, right? And what that does is again, you could hide this SSID from being broadcast if you wanted to, or you could keep it open either way. But we advertise that the secure session available. So if a client joins WT guest and they support OWE, then the client is told in the beacon that there's another service that's available that has OWE, and they should move to that. And then their connection goes from unsecured to encrypted. right? And they don't get those alerts on the phone saying, hey, this network may not be secure and all that kind of stuff, right? So I just wanted to point that out why we were there on the page, but we'll go ahead and apply this. Now, again, just creating the WLAN doesn't do anything. It wouldn't be advertised yet. We have to actually tag it. We have to put it in a tag that our AP is using. Right now, we're doing default tags. Again, in production deployments, we wouldn't use default tags, but this is a lab. We're just explaining this stuff. So let's go ahead and go in our default policy tag. We're going to click Add. And this time we're going to select our WT guest. And we're going to go over here to Wi-Fi training policy profile. That's going to give them the same experience on either of these services, depending on how the user's configured, right? And what the user's capabilities are. So once that's active, we're going to go ahead now and bring up our phone. And let me start, actually, it's cooler probably if I go, we're going to bring up our phone now, because now I've got the recording started. Now it'll show up. All right, so I was connected to Wi-Fi train already. And, here's the thing. If you're associated and you've got a good network signal, Apple devices usually don't scan a lot, right? So you got to give it some time. You notice that it took a little bit to find this stuff. And then all of a sudden more SSIDs appear. That's my device going in the background and scanning, basically in the background to look for other services. So we're going to click on WT guest. And you notice that right now it's saying unsecured network, but it should complete that handshake and it should become secure. Now, I'm curious why it is saying unsecure network, because that should not be the case. Let's make sure we are getting the right thing here. So let's go to monitoring and let's go to clients. This is a brand new iPhone 15 Pro Max. So it is, it's new. Now this is connecting on 5 gigahertz also. So the other thing is it may take it a second to learn about the 6 gigahertz. Now, I've talked about this in other videos, but basically we really want to have 5 and 6 gigahertz networks to be enabled. Doing 6 gigahertz only, we just find some clients just don't roam that well yet. This is still early on in the protocol. A lot of people were thinking we'll just turn on 6 gig for the 6 gig service set and leave it at that. But really it's best to keep them dual band for now. And there's several reasons to that. Watch our Wi-Fi 6E course at Wi-Fi Training. It covers all of those details, but just know that it's typically good to have 5 and 6 gigahertz. So I'm going to go into here under diagnostics and see what we're seeing. And now you see it is 6 gigahertz actually. So I'm going to refresh this. How do I know that? It's channel 213, 160 megahertz. So see this actually jumped over to 6 gigahertz. So that's one of the reasons. Once it finds the better technology, right, it takes a while to find those 6 gigahertz channels. My device is much better to find 5 gigahertz channels and then find the 6 gigahertz channels. So let's do a quick ping test. So I've got ping plotter here, and we'll start a new trace up here. An existing session, start new trace. And we'll just go out to this is the AD server in the pod. So we got a dropped ping there. Wonder if this is, oh, you know what? I'm mapping to the wrong network. My bad. So that's not going to reach because we put them on the internet VLAN. This is going to go to the public. It's not going to route to the pod. So I'll just go to 1.1.1.1 and you can see ping plotter. The cool thing, I love this app. It's a great troubleshooting app, by the way. It's one of my favorite go-tos because, and let me make sure, I don't think I'm still recording. Show you the ping plotter app. Sorry about that. Didn't realize I wasn't recording, so I'll give it some time here. But this is one of my favorite troubleshooting apps because it does a trace from the source to the destination, and then it constantly tries to ping those hops. Okay, so it's looking at the entire path, and then you can also start telling, hey, if I've got latency in a network, right, or I've got issues, I could start pinpointing where those issues are coming from, right? So it's a very, very useful tool for that. Typically, you can use it on a laptop, or you can use it on a device like this, iPhone or iPad, and get to the bottom of those latency or issues where you're dropping packets or frames. As you can see, there's a couple devices there that were not as healthy, right? Because they've got higher latency, right? That 141, 101, 74, 104, somewhere out there, right? You can see that's where the problem with the latency is for that particular session, right? So pretty cool stuff. And I've noticed on this controller, I also don't seem to have device classification enabled. So we're going to go ahead and change that real quick. Kind of a weird video to do this, but let's go ahead and set it up. So we're going to go in here to wireless global and just turn on device classification and apply. That should have been done in initial setup, but it wasn't. So this is going to add some more intelligence. I'm also going to go over here to, let's turn on some application visibility here as well. So we'll go down to application visibility. Now, if you're doing this, guys, with, I'll go ahead and enable all. Actually, our Wi-Fi training policy profile is the main one we're doing, so we'll leave it on that. But bottom line is I can start seeing what apps this device is using, and I get more visibility about the endpoints, right? These are two features that should definitely be turned on all critical services. Now, if we go to monitoring and clients, and if you're using DNAC or if you import your devices with DNAC, you'll notice that's whenever they typically happen. So the screen recording stopped again. It's going to be a pain editing this, but we'll get it done. All right. So we went back to Wi-Fi training, so we're going to have to, I'm just going to forget that network for now. And we're going to come down here to our, now the reason we did that, again, whenever you turn on AVC and you turn on device classification, you're going to notice that you probably drop some sessions. So those should be done early in your controller configurations, right, before you launch the services. And we are just looking for the WT guest, which is up there. We'll join that again. And again, I've got my Apple Diagnostics. So once you get in here and you go to Diagnostics, you can see how it's doing, right? So not the best. We're on 5 gigahertz at the moment, but we should find 6 gigahertz here pretty soon. You can see AX5 there. That 5 indicates 5 gigahertz is what we're connected to. But now check it out. We've got a whole lot more details about the traffic that we're sending, right? If we open up our ping plotter, send some more of that. Okay. And then we should also have more about our device type too. So this host name should change and all that kind of stuff. So unclassified device. So that is because probably the MAC randomization and all that is on. But it would typically pick up iPhone. I'm not sure why it's not doing that yet, but it's all good. We've connected to our OWE service set. That's what's important. And we've got the visibility of ping plotter now. We learned about that. And we also learned about device classification, and at least in concept, because it should start showing us the type of device it is. And you'll typically see that out here. In fact, let's see if I can. Maybe it's something with this new phone. I've got my old one here. Let me see if I can connect it. Now this is not 6 gigahertz. I'm not going to worry about sharing the screen or anything, but I just want to see if this one actually pops up as an iPhone. It's coming up as unclassified device. Now let me turn off private Wi-Fi addressing for this network, and we'll see if it can classify it. Let's disconnect. It doesn't want to identify the device. Oh, yeah. I have private Wi-Fi addressing turned on already again. All right, let me try it one more time. It's crazy, man. These guys want to be secret. That's why it's much better to use, user credentials, device credentials, things like that, other than the MAC address to find your devices, is that random MAC address. Now, a quick note about random MAC addresses: they should only randomize per SSID, meaning if I connect to a new SSID, that random MAC that was used should be reused every time I connect to that SSID. Okay? It should not pick a random MAC every time you connect. It should just do it for every SSID I connect to. I basically randomize the MAC and I associate with that. There is ways to uncover the device type from that randomization algorithm, by the way. We're not going to get into that in this video. We do talk about it at wifitraining.com and the videos we have in there. So hopefully you enjoyed it, and we'll see you in the next one.